about piecewise functions. Now we're going to dive into absolute value functions. And I personally find absolute value functions a little bit easier. So let's go ahead and jump in. So something you should know about absolute value functions is that absolute value functions have only positive outputs in its basic form. And if you think about what an absolute value is, so for example, like the absolute value of -9 is 9 because it's the distance away a number is away from 0. So it doesn't make sense for it to be -9 units away from 0. It's just 9 units away from 0. So the absolute value function, of course, would only have a positive output in its basic form. So we're going to go ahead and look at the absolute value function in its basic form, make some observations, and then kind of use that to guide us for our next examples. So let's go ahead and jump into it. Absolute value of -3, if I'm just creating my input-output table so I can graph my points, well, the absolute value of -3 is 3, because it's 3 units away from 0. Absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. And then absolute value of 1 is 1. So you see I'm kind of like having a patterns. And what you're going to see is that even as the data kind of makes this V shape, oh my Lord, it just wants to do its own thing today. So is our graph. So I got 3, 2, 1, 0, 1, 2, 3. So it builds down, builds back up. And notice how all of those values are positive. So let's go ahead and graph our absolute value function. So I'm going to have a point at -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. So, and then if I draw my lines, the line tool is super dope. I got this really, really, really nice V shape. And so what's really cool about the absolute value function is that you're always going to get this V shape. So if you don't get this V shape, you did something wrong, or you need to include more points. So this is our absolute value function in its basic form. So kind of observe that. Notice that it's got the V. Notice that it's got a negative slope on the left and a positive slope on the right, in 1 unit. So basic form of the absolute value function. So in this example, we're going to be looking at something a little bit more complex. We're looking at the absolute value of x plus 3 minus 5. So you'll notice that I created an input-output table, and I used a range. So I went from -6, 3, 0, 3, 6. And this is because I want to kind of see the whole picture. I don't want to look at just a little segment. I want to make sure I'm kind of covering the whole thing. I'm trying to make sure I capture that V somewhere. So let's go ahead and calculate our output. So I'm going to first calculate my output on the left over here, just kind of as some scratch work, because I know some of us really need to be able to see every step. And so I'm going to kind of offer that to you here in the scratch work, but then I am going to calculate the next values using mental math. So just to set this up, if I'm using the input of -6 and to calculate the output, I'm just plugging in -6 for x into this equation. So I'm going to have the absolute value of -6 plus 3 minus 5. So the absolute value of -6 plus 3, I'm going to treat those like parentheses. I'm just going to work in those first. So -6 plus 3 is -3. So I'm looking at the absolute value of -3 minus 5. Well, now the absolute value of -3 is +3, and 3 minus 5 is -2. Sorry. So I know that my first output now is going to be -2. So then I'm going to have y -2. So using that same process, I'm going to plug it in -3 and figure out what I get. Well, if I plug in -3, I get -3 plus 3, which is 0. And 0 minus 5 is -5. And then I'll plug in 0. 0 plus 3 is 3. 3 minus 5 is -2. So see, I've already kind of captured that V right there. So let's kind of keep going and see what the rest of this graph is going to look like. If I plug in 3, 3 plus 3 is 6. Absolute value of 6 is 6. 6 minus 5 is 1. And finally, if I plug in 6, 6 plus 3 is 9. And then 9 minus 5 is 4. So let's go ahead and graph these points, kind of get an idea of what our graph is going to look like today. So you remember I got -6, -2. Pointing my screen, you can't see that. And then I got -3, -5, which is down here. 0. Am I doing something wrong? Oh, no. 0, -2. Right there. 3, 1. and then 6, 4. So let's go ahead and connect these dots. You can already see, like, I do have that V just roughly looking at it. But it looks like if I were to continue, my V would go off the graph on the left-hand side. So there we go. So I do have that V captured in there. So then I know that I graphed my absolute value function correctly. So this one, you can see it was shifted. It took this picture and then it basically shifted it to the left and then down 5 units, which is actually what that +3 represents, and the -5. So this one, I'm kind of using that same knowledge. See how it's x minus 4? Well, the x minus 4 tells me that I'm going to be shifting it to the right this time, and then my graph is going to go up 2 units. So keeping in mind that I'm going to be shifting it to the right, I'm going to probably want some more positive values. So let's go ahead and create an input-output table again. I'm sorry, my brain stopped working. So if I create my input-output table again, it says, ooh, that was a pretty solid. Good job. Okay, X, Y. These are the ones that I'm terrible at drawing. All right. So then now, knowing that it's shifting this time right 4 units, I'm going to try to choose some positive numbers, and I'm also going to choose even integers. I'm just going to go with -4, -2, 0. Ooh. You know what? We're going to change this. We're just going to go -2, 0, 2, and 4, and 6. The reason why I'm doing that is because I know it's shifting to the right 4, so I know, like, just looking at, if I plug in 4, I'm going to get 0, and the 0 plus 2 is 2. So that's kind of looking at towards the vertex of it. All right, so then now I got to calculate the outputs. So I'm going to just go ahead, do some mental math. Same setup. So -2 minus 4 is -6. Absolute value of -6 is +6. And then 6 plus 2 is 8. So my first output is going to be 8, which I can't graph anyways. And then I'm going to plug in 0. 0 minus 4 is -4. Absolute value of -4 is 4. 4 plus 2 is 6. Plugging in 2. 2 minus 4 is -2. Absolute value of -2 is 2. 2 plus 2 is 4. Plugging in 4. 4 minus 4 is 0. 0 plus 2 is 2. And then 6, I got 6 minus 4. 6 minus 4 is 2. 2 plus 2 is 4. So you can see I got that dip again that I wanted. So let's go ahead and graph our points. This time we'll do our graph in red. Why not? So now we have -2, -8, which is way up here. 0, 6, 2, 4, and then 4, 6. So you can see it shifted to the right, and it also went up 2 units. Oh gosh, I'm sorry, my dyslexia got the best of me. 2, 4. Did I do 4, 2? No. 4, 2 is right here. And then it's 6, 4. There we go. Sorry about that. All right, so now that's better. I was like, that didn't move left 4 units. It's because I graphed it wrong. All right, so there we go. So now I have the V where I wanted it. Again, I just read the bottom number first instead of the top number, so my bad. All right, but then again, you see we still got that V. It's just shifted this time to the right and then up 2 units. So last graph, we have -2 times the absolute value of X. So this one will be interesting. Let's try to see what this is going to do. So again, we're going to create that input-output table. And then this one, we're actually just going to multiply -2 by the absolute value. So this one, I'm going to choose a wide range. Not as wide. I'm just kind of go with the numbers that I had up here. So like -2, -1, 0, 1, 2. So not as wide because I'm not subtracting or adding anything. I'm just multiplying by -2. Okay, yeah, sorry. I thought I had the wrong tool for a second. All right, so I got X, and then I'm just going to do, let's do -2, -1, 0, 1, and 2. And this one, again, I'm just choosing this range because if I preview in it and I just like do some thinking into the future, the absolute value of negative 2 is just going to be 2. So I know that like I'm working with the basic function, I'm just also multiplying it by negative 2. So my y values are going to do something different. So let's do it. An absolute value of negative 2 is 2. Negative 2 times 2 is negative 4. Absolute value of negative 1 is 1. Negative 2 times 1 is negative 2. Absolute value of 0, 0. 0 times 2, negative 2 is just going to be 0. Absolute value of 1 is 1. Negative 2 times 1 is negative 2. And then negative 4, because we're just multiplying by negative 2. So you can see this is actually, if you kind of understand how the points are going to work, it's going to flip the graph. And we call this a reflection over the x-axis. So we're going to have negative 2, negative 4 goes right here, negative 1, negative 2, 0, 0, 1, negative 1, and 2, negative 4. So this one, we call it a horizontal, a vertical stretch because it's stretching it. And then it's also, oh my gosh, it's flipping it over the x-axis. So I have not finished my coffee this morning, so I really apologize, guys. All right, so there we go. Connect my line. So I have the V, it's just flipped over. And you can see that it's also kind of like stretched out. So it's like it's becoming much taller now, right? Whereas this was a fat V. This is not a fat V. Oops. So now, hopefully you have an idea on how to create an input-output table. So again, you're working with the absolute value functions. Your key is going to be to create that input-output table just so you don't get lost while doing it, and then graph the coordinates from the input-output.